What is good, beautiful people? Today we're going to be looking at Langchain. Specifically, we're going to get you set up with your OpenAI requirements, your Google requirements, and your Hugging Face requirements, so you can use ChatGPT 4, GPT 4.0, or whatever you want. Gemini, Palm, whatever suits you for Google, and Hugging Face has a whole suite of models, but you're probably interested in Llama 3. So I'll go over all of the pros and cons of using each one, how to do it, and when to do it. All the code is in my GitHub. There are also some Colab notebooks in there that are pretty useful. There is a ton of resources on the GitHub that I use all the time, and you should too. So let's get to it. All right, so let's get to it. This video is going to have a lot of information, but we're going to go pretty quick, and I'm going to make separate videos for Google specifically because it is a nightmare. So to get started with Langchain, you're going to have to set up a ton of accounts, and we're just going to get to it. First is Langchain Langsmith. Langsmith is fantastic. If you're used to weights and biases, this is not the same at all, but comparable in that you can watch the model do its thing. Very useful, and it's good to have. So set up an account with Langsmith. OpenAI. So set up your OpenAI account. Also super simple. Both of these I log in with Google and it maybe 2 or 3 clicks. Don't need to really go into this. Then there is Google Cloud. You are going to need to set up a Google Cloud. You are going to need to make a project if you want to use Gemini, or if you want to use the chat vertex AI, and the chat models are going to give you tool use, which is useful for graphs. You can use tools without a tool calling model, but you cannot force the model to use tools in the way you would want to if you're using a graph. And I'm using LangGraph pretty much exclusively as opposed to Agent Executor, and that'll have to be something we explain maybe today, but maybe not. So you're gonna have to set up a Google Cloud account. And finally, Hugging Face. Hugging Face has a ton of models that are open source, that are free to use unless they're too large. So in this case, we're going to be using Llama 3. Llama 3 is too large and requires a dedicated something. It requires you to either have it locally or use an inference endpoint. And unfortunately, if you want to use the chat model so you can use a graph, you're going to have to make an inference endpoint, and it costs about $1 an hour for Llama 3 8B and about $16 an hour for Llama 3 70B, which ends up being cheaper if you do the math than using OpenAI, which for a graph, since you're making a ton of calls, I would say each graph run costs about 30 cents. And you can see that in the Langsmith here. You can see, look, this is all OpenAI, and it gets pretty expensive. Up to almost 40 cents on some, but down to about 1 cent on others. I've spent about $8, well, quite a few hours. But those are the accounts you need to set up. Once you set those up, we can move on to the next step. All right, so I recommend setting up a Conda environment. Pretty simple. If you don't have Conda, I have a video explaining that. There are a ton of imports, as I've said before, so you're gonna benefit from just doing a pip install for this requirements.txt here. As you can see, pretty much anything you do, there's at least 10 imports, and it gets pretty hairy. So I would install the Google Colab. You can either clone this repo or just copy this into your own file and get those installed as well. And if you're using Google Colab, which I would recommend in some cases, there are some times when it is better to run this on your own device, especially if you have a nice GPU or if you are doing some kind of manipulation of stuff on the system, or pretty much anything that is going to require terminal use. There's some troubles here. If you are using Google Colab, it's the same thing. Just upload the requirements.txt file into the working directory on Colab, and you can do a pip install. Or you can go to my GitHub, and I don't use the requirements.txt, so I have these in there, and you can either copy it or download the file for yourself. It's pretty much 50-50 split on Colab versus local. I usually start on Colab and then move things over as I progress. Now let's do a little opinion on OpenAI versus Google's suite of models. Hugging Face, we're not going to include in this comparison because the models are worse. That's just how it is. They're not as powerful. Some aren't multimodal, but there are a ton of them. So a comparison doesn't really make sense. They're also generally free to use unless you're using a server or something else. So in that case, you're just paying for hardware, not so much use, which I feel like in this case, you're also paying for hardware. Technically, they charge it by token or character. So let's start with OpenAI. It's capable. It does what large language models are thought to do. It's got the most support and features. So it started the whole functions. It started the APIs for this thing. It's got Langchain, Llama Index, all the others. They're all built with OpenAI in mind. So it's easy to set up. The account is easy to set up. You just make an account and you're in. It gives you a key right away. So compared to Google, there's really no cons. I would start with OpenAI's API. So the models that I would recommend using are GPT-4o, GPT-4 Turbo, and GPT-3.5 Turbo. GPT-4o is multimodal, about $5 per 1 million tokens, but I find it to be worse than GPT-4. And going from GPT-3.5 to GPT-4o, they lose their rigorousness in following instructions. So GPT-4o, it tries to be creative. If you say respond with the letter A, if I type the letter C, it won't simply respond with the letter A. You have to do a pretty extensive prompt with examples just to get it to respond exactly how you told it to. Whereas GPT 3.5, I find it's the best at following instructions. It might not be the most capable, it might not have, the greatest logic, but if you give it a set of instructions, it follows the instructions to the T at a greater frequency than GPT-4o or GPT-4 Turbo. GPT-4 Turbo is also multimodal, and for these OpenAI models, multimodal just is text and images. $10 per 1 million tokens. It's about twice as expensive. I think it's the best overall model out of all of them. Even Gemini stuff. It's not what I always use. I'd usually, if I'm just trying to do something quick, I use Gemini. I have a pro account, so I usually use that on the browser. But for any applications where I want to, do some kind of Langchain stuff, I'm probably going to start with OpenAI or use Llama 3 because free, unless I'm really paying $1, I guess. But it's pretty cheap. GPT 3.5 Turbo, that's text only, and it's 50 cents per 1 million tokens. So it's the cheapest, and it's the best at following instructions. So with Langchain, I don't know, there should be examples on the GitHub. I would use both GPT 3.5 and GPT 4 Turbo. Usually I'll use GPT 3.5 to format outputs if it's more complicated than using the parser. So sometimes I might want to format the output in JSON, and I'll have GPT format it, and then I'll use the output parser to actually just extract the JSON. We'll go over that in future videos. You can use them together, and they're pretty cost effective that way. All right, so Google Vertex. It's got the most features. It's a whole suite. It's not really an API. It's a whole thing. There's a lot there, and it's hard. It does technically have the cheapest models. The cheapest models aren't really worth using. So I put that in there because if you want, I haven't actually tried this, so I can't say how effective it would be. But since I do use GPT 3.5 and GPT 4 together in a system, I'm sure you could use some of Google Vertex's available super cheap models, some kind of pipeline as well. The interface is extremely complex, and it requires multiple accounts. It's got a long initial setup, and there's limited integration. So Langchain allows you to use it, but it's clearly not a priority, and it's kind of an afterthought. And that seems to be the case with everything. Complex interface. I mean, it is really hard to use this thing. And here's the pricing. Gemini 1.5 Flash is the fast model. It puts out outputs pretty quick. With the inference engine on Hugging Face, I feel that Llama is faster, but they're both pretty much instant at this point. Even OpenAI is pretty dang fast. The time comes in when you're doing a loop or some kind of chaining. They get pretty slow, but if you're just doing some queries, it doesn't take more than a second to, maybe not. It definitely doesn't take more than 5 seconds to get an output with text. I guess with images and video, it does take quite a bit, which these offer. These offer video support, which is pretty awesome. But again, videos are images. So there was some little debate going on. There's no debate. A video is a sequence of images really fast. I guess it's not really, but it is. There is some kind of context issue and some other things that using video harder, but at the end of the day, it's a series of pictures. So they price per character, and they're doing whatever this number is per 1,000 characters. So per 1 million characters, that's just gonna move it back 3 places, and then multiply that by 4. I moved it back 4, so it should be 40 cents per 1 million tokens, which makes this extremely cheap. Assuming that 1 token is 4 characters, may or may not be true. And then the price goes up after 125,000 context length, which is way longer than GPT-4o doesn't go that high. So you can really get some good context in here. The thing is that there's an issue with active context, and just because it has a super long context doesn't mean that it is necessarily effective. You're going to want to do some RAG or something like that if you're going that high in context. For examples, though, if you want to provide examples, if you're doing some of the ICL in context learning methods, this is definitely your best bet. GPT 1.5 Pro, they actually all cost the same. And again, my math is a little bit wrong here because we're going to move back here. 10 times 4, that's about 50. That's about 5. So the maths, this is actually 10 over. So these are actually way cheaper than OpenAI. I take that back what I said before. I find GPT 1.5 to be more interesting than GPT-4. So also has trouble following instructions. I use it in my browser quickly, and I find that for code tasks, for text generation, it does things that I wouldn't expect, and I'm happy to see. So a lot of times with code, it'll put in some secret sauce in there that I've never even seen before, that's pretty creative, that I didn't ask it to do, but I'm happy that it did. And that happens more often than it doing some secret sauce that doesn't work, that I'm not happy that happened. So the outputs are more interesting. It feels more like you're talking to a person that's trying to help you. And I don't really know how to describe that, but that's my opinion. That's why it's an opinion. GPT 1.0 Pro, there's really no benefits to using this. It's inferior. I'd say it's on the level of GPT 3.5, and it's worse because it doesn't follow instructions as well. So it's also kind of creative, I guess, but it doesn't. It's not as high performing, so it's not worth using in my opinion, and it costs the same. So really no benefits here. So that's the comparison of those two models, of those two services. All right, so what is up? Let's get some code going. Just the basics here. How to start a chain going. So we're gonna use OpenAI. We're gonna use a chat model here. Again, the chat model gives us the ability to bind tools to the LLM and allows the LLM to select tools more intelligently. You still can use tools with the regular non-chat model, but the chat model is preferred. Unfortunately, a lot of the non-OpenAI LLMs do not support chat models. We'll get into that in the future. So let's start here. We'll do OpenAI and we'll go through all of them. So first you want to import Langchain OpenAI, and you want to set the LLM. That's just a variable. You can call it whatever you want, but this seems to be convention. Again, this is about a year old, so the conventions are pretty much made up. And we can go to Langchain core prompts to give us a chat prompt template. That's not necessary. You don't actually have to do this, but the chat prompt template is just going to make things a little bit more convenient for us here. So we'll go ahead and import that. And then this is basically it. So when you set up a chain, you are basically setting up a series of events that you want to have. So in this case, I want to start with the prompt, load that in, and I want to pipe it to the LLM. And at this point, I am not going to do an output parser, so we can just see what the output is. And we'll do a chain dot invoke, and we'll set things up here in a second. First, we have to define the prompt. And for the prompt, we will do a chat prompt template dot from messages, and we will define a system prompt, and we'll say you are a helpful AI assistant. That's kind of the convention, and then just to show that it's actually doing it, finish each response with I have read the system. I guess we should start each response with that. And then when we define the user message, which is the input, basically we are going to F string syntax, but you don't actually do the F string, so we'll just put an input here, and that should be good. We should be able to invoke from there. So I'm gonna go ahead and import this, and I'll probably move this over to Colab so that we can see the output per cell. And I guess before I come back, we do want to pip install Langchain core. Perhaps I didn't. It should install with Langchain, but either way, let's go ahead and add it here. Langchain core, and for some reason it's a dash for the pip, but it's an underscore for the actual import. So just keep that in mind. All right, let's move over to Colab. All right, so we're right back at Colab. We're going to do a pip install for all these things. This is just the general, what I use for everything. So there's more than we need. We should be able to get away with just Langchain OpenAI, and Langchain core. Actually, yeah. So it has installed. We've gone ahead and set up the LLM. We'll go ahead and run that cell as well. And here, chat prompt template. Whoops. Right, I didn't put the OpenAI key, so I'll do that in a second. And the chat prompt template, all we're getting is the roles as opposed to a prompt template template. There are no rules specified, but you can add them. So really at the end of the day, it's you know, I just use chat prompt template. If I'm using the chat model, why not? And so when to run the chain, you do invoke, and that's going to send the value here to the value specified in the prompt. So in this case, all we have is the input, and the question is, when was the Declaration of Independence written? And that's July 4th, 1776. So I'll go ahead and import the OpenAI key, and we should be good to go from there. All right, so to import the key, this is the simplest way without having to actually include the key in your code, or you can also do it a .env or a config file, JSON, whatever you want. Those require you to have the key stored somewhere. This just lets you copy and paste it in. So it's pretty simple, and it kind of cleans things up. So we should go ahead and run this, and we should go ahead and run this and see what it says. All right, so without the output parser, you can see here that it responds kind of with the full output that these LLMs are, that they give out. It gives a little more information. We're using GPT 3.5 Turbo. I thought the default was 4, but either way, Declaration was written in 1776. I would have preferred the full date, but that's correct. It was published in 1776. I'm sure it was, you know, maybe it only took a year. Thomas Jefferson, you know, he's doing his thing. That's it. So let's try and add the output parser. We're going to want to do langchain underscore core dot output parsers import. And we're just going to do the string output parser. And what that's going to do is extract the string from the content section here, which is what we want. So output parser, and actually you don't have to define that. You can, in the chains, you can put whatever you want. It can be a function, it can be anything, it could be a variable if you want, which is not very useful, but it can be. So we'll just go ahead and put this in here, string output parser, just like that, and we can go ahead and invoke the same thing. All right, so that's the content. I did tell it to start each response with "I have read the system message." It has done that, and the Declaration of Independence was written in 1776. GPT 3.5 Turbo I do like because it just follows the instructions. I'm sure this is pretty simple, so if we did add GPT-4, it would probably respond the same way. So let's give that a shot. All right, so GPT-4o. GPT-4o is cheaper. I don't think it's better than GPT-4 necessarily. I think the hype is that they made it easier on the application, on the phone app, to do multimodal functionality, which is pretty cool. But in terms of output quality, I don't know. But here we go. We got a little more information. Instead of the Declaration of Independence was written in 1776, they added another sentence. It was adopted by the Continental Congress on July 4th, 1776, which is why the date is celebrated as Independence Day in the United States. And as you can see here, that's not what I asked. I asked, when was the Declaration of Independence written? It was written in 1776, may be true. It might have been written before that. I didn't ask when it was adopted. But you know, it's kind of the inferred meaning of what I was asking, so I'll accept it. But you know, GPT 3.5, I think that should be clear that it follows instructions better, in my opinion. So if you have a simple task, GPT 3.5 is what you want. Anyway, so that's just the basics. Let's see what we got here, and we'll try something else in a second if time permits. All right, so this is going to require a separate video just because we want to keep these under, you know, 25 minutes. And we're already at the 17-minute point. But so for G-Cloud, we'll have to go into setting this up, and it is quite intensive, but you are going to need to set up a G-Cloud account, and we want to use the Vertex AI service so we can get the chat model. Without the Vertex AI, you have a chat model, but it doesn't have the tool support that we're looking for. So it's going to, instead of a key, you have to init a G-Cloud session, kind of similar to Ollama, except it doesn't run locally. Once you init the session, then you import the model with the project. You initiate the model with the project ID, the location, there's only one location, and the model name that you're looking for, and the project number. You actually don't need the project ID, you just need the project, but we could put that in there anyway. And we have a response, which is just going to, instead of doing the template, you can directly set the the role here. It's not really a role for Vertex AI, but same idea, and the content. It's the same setup here, except I've just put it in one line for simplification. We'll do it exactly like it is done here in the upcoming video. And once we print the response, it gives us a response. So it doesn't have access to real-time information. We did include a search tool, which we could do, and it goes on like that. These will all be on the GitHub, so if you want to get started early, just check that out. And for Hugging Face, we have a couple options for Hugging Face models. We have the serverless inference API it's going to basically load from Hugging Face and try and run directly. Unfortunately, this model's too big. It needs to be, I think, under 7B basically, and this is a little bit over that. So it looks like 10 gigabytes. This is 141 gigabytes. That's just because I'm doing the 7dB, and it's technically twice the billion parameters. We'll get into that. So I guess really a 5 billion parameter model. I think you can do a 7 billion with. I've done that before, so perhaps there's something different. The inference endpoint is what we're using. That's going to require money, and you have to set that up. I think I do explain that a little bit, but we'll get into that. And then transformers without Langchain at all. You set up a model through the transformers pipeline, and you can wrap that with the Hugging Face pipeline. And so you have a model that's usable with Langchain, but it's not a chat model. So you can use tools with it, but it is not optimized for tool use. You can't bind the tools to the model and force it to use tools given certain conditions. You're going to be stuck with the agent executor, which is fine, but it's not great compared to using a chat model. So that's basically it. So here we are. What did we set up here? Okay, so we are doing a chat model here with tools, and we already using the agent executor here. So we could use any of the models with this agent executor, and we should be okay. But we're not going to do that. And that's coming up. Here's the same thing with just the pipeline transformers, no llama. No Langchain at all. So you'll see that all on the GitHub. And that's gonna wrap us up. Let's call it a day here. We'll do another specifically for Google Cloud, and then specifically for Hugging Face coming up. And that should set you up and give you the basics. And then from there, we'll actually start doing the graphs, which look like this. There are some graphs on the GitHub as well that you can check out. So I hope your day is better than mine. Be easy out there. And again, email me, please. I respond to those. Or you can post an issue on GitHub, or you can post a comment. All those are viable ways to contact me. I am here all day, every day. Peace. All right, a little addendum. I think I said that all the chat models support tool calling. That's not the case. The chat Hugging Face doesn't support tool calling, but it is a chat model, so you can use it with the roles and the other system that you have available, all these extra things that are a little bit helpful, as opposed to just having an LLM in a pipeline. So you can use it as an agent, which is probably helpful. Otherwise, you can only instantiate the LLM and not an agent. So you can use this with the agent executor, but you can't use this with a tool calling feature, which you would need to run in a graph. The graph requires you to bind the tools so that you can specifically force the agent to call a tool given certain conditions. And the list of tool calling models is here. Now, if you're using the agent executor, you can use tools, allow the agent to use tools, but the agent is going to have to decide to use the tool on its own. And that is not always great, but it is better than just having the LLM, in which case you're forced to use a chain, and you don't have the option to have the agent reason as to when it's appropriate to use the tool or not. So even though you force it to use a tool, it reasons that this is the time to use the tool that you force it to use. Or you can use it in the agent executor, and the agent executor will decide on its own whether a tool is available and try and make some inferences from there. So it's a little bit more relying on the LLM with the agent executor as opposed to the graph setup. And with the chain, you are not specifying tools at all, and you have to actually pass the tool as part of the chain, which doesn't flow as well. You have to define things a little bit more. So that's just a little addendum. Peace.